Hello, and let's go over our third learning goal for the thermochemistry unit test. This learning goal is also the essential learning for your test, which means you have to demonstrate proficiency on this section with at least a 70%. Otherwise, we'll have to redo it until you can. It will also be 70% of your overall test grade. So if you're good at it, that makes it really easy. So the learning goal, or our essential learning, which is the sixth essential learning for the year, is that you can calculate the enthalpy of a reaction and then also identify it as endo or exothermic based on the value. Okay. So to solve these problems, you will need the standard enthalpies of formation chart. Just so you know, I will give you all of the values on the test. So what I'm really evaluating is not that you can look up the numbers, but that you know what to do with them. Okay, so when you do your review, you'll have to look at them up, but on the test, you'll use the ones that I'm going to provide for you. Okay, so let's check out some examples here. First thing, I have my standard enthalpies of formation chart. You shouldn't have a hard copy of one of these unless you stole one from me before spring break, but I doubt you did that, right? And what you'll have to do is look it up on Google Classroom. So down in the thermochemistry unit, you will find it there. You can also look them up on Google. The problem with that is if there's any difference in the numbers, which definitely happens, then that's going to make our values be off. So it will be a little bit confusing. Okay, so pull up that document so that you can try those practice problems, and let's check out our first example. Okay, so first thing we have to understand when we're doing these problems is that there was a chemical reaction that occurred to form these molecules. So lead 2 oxide formed from a chemical reaction, and there was energy involved in that reaction. A group of scientists have already sat down and figured out the value of energy that is stored in the bonds of that lead oxide or lead 2 oxide from when it formed together. So what you're going to do is you're going to look those values up. Okay, so you're just going to flip through your standard enthalpy chart. I probably should have done that ahead of time because this is going to kind of take a minute. We go to the lead section. Remember that it's in alphabetical order by the first element. And it is very important that you keep track of the symbol. Also, remember that this means solid, liquid, or gas, the state that it's in, because some of them have different values for different states. So lead oxide has a value of negative 219. Okay. Then I'm going to do the same thing for the carbon monoxide. So let's see here, carbon monoxide, and it is the gas form is negative 110.5. Lead is a pure element. Remember that pure elements don't have a heat of formation because they just have always existed. So their heat of formation is 0. You can look that up too if you forget. And then finally we have carbon dioxide. And again, it's carbon dioxide in the gas form. And that has a value of negative 393.5. Okay, so now I know how much energy is trapped in those bonds. So when they all react together, I can calculate how much energy will be involved in this particular reaction. Okay, the equation to do that is that you're going to take delta H is equal to the total products minus the total reactants. Okay, so when I solve these problems, what I like to do, just to sort of make things easier, is start by finding the total on each side and then plug it into that equation. Otherwise, it kind of gets to be a lot. So obviously for the product side, my total value is going to be equal to negative 393.5, since it's 0 and 393.5. And of course, we all remember that total means addition. And then for my reactant side, the total is going to be those two numbers added together. So 219 plus 110 would be negative 329.5. Okay, so now I'm going to plug it into the equation. And again, it's my products. So negative 393.5 minus my reactants, and in this case, my reactants are 329.5, so minus 329.5. So if you were to plug this into your calculator, depending on if you're using a scientific calculator or not, you would need to make sure that you included these signs. I like to make my life a little bit easier, just take care of this. Do you remember what happens when you subtract a negative? It becomes positive, right? So I'm just going to write on there that that becomes positive. Okay. So then I'm just going to take negative 393.5 and add 329.5. And I don't feel like doing the math in my head, even though I totally should be able to. And I get negative 64. And of course, the units for that are kilojoules. Okay, so my answer is negative 64 kilojoules. So that's how you solve one of those problems. And then the other part, the other just as important part, is that you have to identify that reaction as endo or exothermic. So if it has a negative value, remember that this represents energy release. So when this reaction occurs, there is more energy released than absorbed. So this reaction overall is exothermic. Okay. All right, so let's check out one more. I'm going to double check here. I will definitely give you all of these values on the test for sure, so you won't have to worry about one being missing or anything crazy like that. So again, same process. You're going to start by looking up the values, okay? Notice here that for this reaction, there was just one of each of those molecules, so it was really easy. In this next problem, it's a little bit more exciting because we have two of some of the molecules. So we're going to talk about what we do here. So again, I'm going to look up the value for the silicon tetrahydride, which is 34. And oxygen is a pure element. So again, it would have a heat of formation of 0, and there's two of them. So we're going to multiply that by 2. Of course, the answer is still 0, but just so that we all kind of see that. Then I have the silicon dioxide, which is the same thing as quartz. It has a value of negative 910.9. So lots of energy is released when silicon dioxide forms. And then finally, we have water. Again, notice that it's liquid water and that there are two of them. So make sure that you look up the right value for liquid water. See here, and I should by this point have it memorized, but I don't. It's negative 285.8. Okay. So again, I really want to point out that when you do these problems, you have to multiply the heat of formation by however many moles are involved, because if there's more than one mole of the molecule involved, then that means there's going to be that much more energy. Okay. So again, I'm going to total my value. So 34, right? Plus 2. So the total is 34. Okay, that's my total. And then over here, I'm going to total these values. So I'm going to do negative 910.9 plus 2 times negative 285.8. So let's get out our handy calculator. Times 2 plus 910.9. And we get over on this side a negative 1482.5. Okay. So now I'm going to plug it into the reaction. Again, remember delta H is equal to the total of the products minus the reactants. I'm just shortening it up for, whatever time's sake. So the total of the products was negative 1482.5 minus the total of the reactants, which was 34 in this case. So we're doing negative 1482.5 minus 34. And you can just plug that into your calculator, and you get negative 1516.5. And of course, the unit is kilojoules. Okay, so that's our answer. And because that number is negative, what does it tell us about that energy? That means that that energy is lost or released. So that's how much more energy is released than we started with, right? So that means we would have an exothermic reaction. Okay, if the number is ever positive, and they're not super common, but if the number is ever positive, then that would be an endothermic reaction. Okay, again, you have, let's see here, 6 of those to do on your review for the test. I think you're going to have to look up silicon tetrafluoride, so just type that into Google to solve that problem. But go ahead and give those a practice, and it's really important that you practice those because that is, again, your essential learning. So that's 70% of your test value, and you do have to get a 70% on it in order to get credit. In other words, you're going to get to redo it until you do.